Hi everyone, welcome to my channel TCU for Olympiads and JEE. Today I am back with another video on the series one question series of mathematics. I have not added that slide today of that introduction. Let's start with the question directly. It is telling a student did not notice that the multiplication sign between two 7-digit numbers and wrote one 14-digit number. Means let's say we have a 7-digit number like this: A3, A4, A5, A6, A7. Another 7-digit number, but it was separated by multiplication sign: B1, B2, B3, B4, B5, B6, B7. Whenever we write a number, we write a bar on it. And so yeah, this is B7. This is a number separate, this is a number separate. But the student has done it that A1, A2, A3, A4, A5, A6, A7, B1, B2, B3, B4, B5, B6, B7. This is what he has done. Made a written a 14 digit number. Right? So, which turned out to be 3 times the would-be product. Means this product let to be P. So, this is 3P. Right? Now, what is the question says? Check whether such a situation can arise or not. If yes, then what are the initial numbers? And if not, we need to prove why. Right? This is what the question says. I am erasing everything. Now, let's start with the question. So, first of all, let us write the number. We can write that 7-digit numbers as A and B. Separate 7-digit numbers. This is one and this is another. So, what the student has done, we can write that to be A into 10 to the power 7 plus B, right? This is what student has done. Right? And the would-be product was A into B. And we are told that this A into 10 to the power 7 plus B equals to 3AB, right? Now, what we can do is, taking this B this side, we can write A into 10 to the power 7 equals to B times 3A minus 1. Now, taking this entire thing here now, we can write B equals to A into 10 to the power 7 by 3A minus 1, or equals to A by 3A minus 1 into 10 to the power 7, right? Now, here's the fact. We need to check, we need to have the idea that now we can say this thing. GCD of A comma 3A minus 1 is equals to 1. It is always true. We can prove this by Euclid's lemma as well, or just our normal GCD method. 3A minus 1, here 3, here 3, then here comes 1, and so GCD is 1. Always. Yes, except A equals to 1, that's obvious. And even if A equals to 1, then also GCD will be 1 only. So GCD is 1. Right? And okay. Now, since this GCD is 1, so we can write this statement. This is the output, this is the conclusion we are getting. 3A minus 1 is a factor of 10 to the power 7. Right. We can say this. So, now we need to move on. In order to move on, we can say another thing. From this way to derive a conclusion as well. Like what I can say, 3A minus 1 is a factor of 10 to the power 7 which we got. So we can write that 10 to the power 7 plus 1 has a factor 3, right? 10 to the power 7 plus 1 has a factor 3. No, 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 that's not the case. Wait a minute. We can say this from here. So what we can say is, we can write this as 3a minus 1 times some d is equals to 10 to the power 7, right? Since b is an integer, we are telling this. So 3dA equals to 10 to the power 7 plus d, right? Which means 3 is a factor of 10 to the power 7 plus d. Okay? 3 is a factor of 10 to the power 7 plus d. What happened? Yeah. 3 is a factor of 10 to the power 7 plus d. Now, let's say d equals to 2. If d equals to 2, that is 10, 1, 0, 0, 0, 0, 1, 2, 3, 4, 5, 6. Okay, I'm not writing it here right now. I am rubbing this part, this thing, this yellow part now. I am rubbing this. Yeah, I have space right now. So what we can write is, let's say, let d equals to 2. Because 3 is a factor, we can write this as, so this is what the number is, 1, 2, 3, 4, 5, 6, 2. Okay, this is 6a. So a comes out to be 1, then we have 6, 6, 6, 6, 6, then we have a 7, right? Have I done correctly? Okay, then moving on, let's say d equals to 5. We had in other cases, this thing will not be divisible by 3. This thing, this, or else this will not be divisible by 3. We know the sum must be divisible by 3, right? And in this case, we will have something like this equals to 15a. Now, in this case, it may be possible that a is an integer, but a will not be a 7-digit number, will not be a 7-digit number, right? So, now I can conclude that a is just equals to 1666667. This is the value of a. So, what is b? B is 1666667, right? Okay, sorry, I've done one more. 6, yeah. 6, 7 into 10 to the power 7 divided by 3 times this thing minus 1. 3 times this thing minus 1. So, on calculating this 3 times, what we will get? Here 1, then we have 0, 0, 0, 0, 0, and here we can get 3, so 5 minus 1, and this is clearly 5 into 10 to the power 6, right? This is 5 into 10 to the power 6. So we can write this as 5 into 10 to the power 6, here 10 cancels, here 2, so our b is equals to 4. Then we have here 3, 3, 3, means 3, 3, 3. Is it like that? So our numbers are this and this. Answers, whatever I can write the answer. answer. So our answer, we have got this A equals to, okay, let me change my color for the last time. Yeah, what I've used here. So what I've got, A equals to 1, then 5 sixes, then a 7. B, we have got 6 threes, and then a 4. Right? Okay. So thank you, slide came apart. So these are our answers. And this case, this part we have got a big yes. It's possible, and the initial numbers are here. So I hope you have understood the solution. I am just revising it once, but I have erased the maximum part of it. We have choose the first number as A. We have choose the first number as A. The second one as B. And we have written 10 to the power 7 times A plus B equals to 3AB. From there, we simplified the equation and came to this. Then we simplified it again and came here. Here we got this, and now we came to this conclusion. This GCD of this is equals to 1. We proved it here. Why it is 1. Now we can write that 10 to the power a minus 1 equals to 10 to the power 7. Now we wrote this 10 to the power a minus 1 is 10 to the power 7 again. And now we multiply this by d. D must be an integer. D is an integer here. And this is 10 to the power 7. So we can write this as 3dA equals to 10 to the power 7 plus d. Or 3 is a factor of 10 to the power 7 plus d. Now we put d equals to 2, d equals to 5, and we saw that after 5 all numbers will be, if we find the value of a at last, that will be less than a 7 digit number. It will be 6 or 5, something like that digit number. So this is not a 7 digit number. So we have only one case where d equals to 2, and that is 1666667, right? And on putting the value of a in this equation, we got this as b. On calculating, b calculated out to be this, and so we can write our answer as a equals to this and b equals to this. Okay, now that's the end of our solution. Moving on to our last slide. Thank you slide, and thank you so very much for watching the video till the end.